Good morning, everybody. My name is Hanno van Raalte. I'm product manager for Moldflow, and today I was asked to give everybody an update on what's new in Moldflow 2017. So I will go through a presentation. I think I have enough material to easily cover an hour. This is a fairly condensed version of what actually is in the 2017 release, so there's actually a little bit more than is in this presentation, but I'm trying to stick to the highlights. If you want to have in great detail sort of what's in the new 2017 release, there's actually a lot of information in the what's new material. It's in the help functionality of Moldflow 2017, as well as the validation documents that are going to be made available in the next couple of days. So, my name is Hanno van Raalte. I'm product manager for Moldflow. I've been involved with injection molding simulation for quite a while. I started in '97 with a company called Cmold, which was a competitor of Moldflow at the time. In 2000, Moldflow acquired Cmold, and I became part of the Moldflow team. The Moldflow acquired Cmold and became part of the Moldflow team, and so now we're part of Autodesk, obviously. And I've done many things over the time. And in the last 8 years, I've been product manager for the Moldflow products. So I'll go over a number of the changes that we've worked on in the last release around licensing and entitlements changes, usability improvements, some material data and solver enhancements. I have a number of videos. If we get to them, if we have time, I'll show a couple of videos. Otherwise, I'll skip those, depending on the time. I'll talk a little bit about some of the other products that are in our ecosphere, what's happened with those, and where they're at, and what's going to be made available in the next release for that. And I have a session on for quality and questions and answers. So let's get started. So that we have our release basically built up in 3 different sections, and I won't go into the great level of detail in these particular slides, but we made some licensing changes, we focus on usability improvements, and a large area dedicated to some new features, new capabilities that we introduced in the software this time around. So don't bother reading these things in great detail. We'll head those in the remainder of the presentation. So most of the customers have had Moldflow for many years, and they bought a perpetual license over time and basically bought subscription on top of that to get access to the latest release, as well as get access to our support organization for asking questions. So that framework is very traditional, and it will still, if you have like a perpetual license, you will going forward still be able to buy your subscription the same way as you've had over time. So for the existing licenses that you have right now, no change whatsoever. You can keep renewing those in the same way you've always had. But I would tell you, like, keep them on subscription. As soon as they're off subscription and you want to get back on subscription, they will actually you will actually have to buy sort of a term-based license instead of going back on a perpetual maintenance scheme. So going forward, every new license that you buy will be a term-based license. So you may buy a subscription for like a year, and you can look at it like buying a subscription for a magazine. You buy that for a year or 2 years or 3 years. You pay amount of money for that, and during that time you will receive the product. In this case, like it's a magazine. The same way it works for us for our software going forward. For every new license that you buy, it will be a subscription license for a year. So at the end of that term, the software will stop working, and you will buy a new term license. So one of the benefits of this is that it actually, the upfront costs, so to buy the technology, actually is going to be significantly lower than with the perpetual license, where you basically make a huge expense up front, and pay a little bit into that system going forward. Whereas with the term-based license model, the upfront costs are significantly lower to get access to the technology. The other benefit is that subscription type licenses work a lot better in some organizations for because it comes out of a operational expense, which typically is easier to get approved than a capital expense, which would typically be the purchase of a perpetual license. So the approval process typically would be a little easier within companies to get through. Another benefit is that it allows companies to scale capacity a little bit easier. If you, let's say, have for about a year or 2 years a larger project for which you need a license, you can actually, for the duration of that project, buy a license at a lower cost than you would normally get if you buy a perpetual license. Another fairly big change that we made this year in terms of the product packaging and capabilities is that where in the last couple of years we had Moldflow Insight available in 2 flavors. We had sort of the perpetual license, where you can, the more traditional license, if you will, where you can submit an analysis to a local machine, or sort of to your local machine, to your own personal laptop, for instance, or to your a machine in the network. And then we had the Moldflow Flex license, which basically allows you to run one analysis on your local machine, or you submit your analysis to the cloud. So in terms of functionality, they would be very, very similar, although Moldflow Flex was basically would provide access to the superset of the product functionality, the Insight Ultimate. But in terms of the user interface and the way it works, actually, it would be very similar to the perpetual license. One thing we did this year is we basically merged those 2 product lines into one. So whether you had a Moldflow Insight perpetual license or a Moldflow Flex license, you will get access to the exact same functionality you had before. But in addition to that, you can now submit analysis to your local machine, submit analysis to a machine in the network, or you can submit analysis to the cloud. So if you had a Moldflow Insight perpetual license, for every solver license that you have, you get an entitlement, or the rights to submit analysis to the cloud. The only thing you're going to need to do is buy some cloud credits to run, and this you have to equate with fuel in a tank. So you get the ability to run in the cloud, but in order to actually run the analysis in the cloud, you're going to need to buy some cloud credits to run. So this helps you actually, let's say if you have a big project to complete, let's say by the end of the week, and you know that you don't have enough analysis capacity with your normal licenses, if you will, to get that done before the deadline, buying a couple of cloud credits to actually get access to nearly unlimited compute power, the ability to run additional solvers on the cloud, more than you would be entitled to on your sort of normal license, if you will, would be able to rope in your deadline and make your project fits the deadline that was set for you. If you had a Moldflow Flex license, you actually get some additional benefits as well. So you basically were in the 2016 Flex version, the amount of you would only be able to launch one analysis on your local machine. With the new Moldflow Insight 2017 license, you would actually get access to Moldflow Insight Ultimate functionality, which we had before, but you would be able to run 3 simultaneous solves on one particular license. So on your local machines, and you would be able to run somewhere else in the network. So you get more flexibility in terms of where you run and how much you run behind the firewall. So
Hi,
another
Hanno.
thing. Yep. Hey, Kate.
Before we move on to the DOEs, there was a question come in that I think might be pertinent to
Yep.
what you just are reviewing right now.
Yep.
Mark asked, in 2016, regardless of having Premium or Ultimate, you still have to pay for cloud credits.
Correct. So if you if you started with Moldflow Flex 2016, you had access to cloud credits in order to run in the cloud. That same still applies to the Moldflow 2017 release. So you're entitled to, you're set up effectively to run in the cloud. There's no barriers other than the fact that you need to have cloud credits in your and consume cloud credits to run in the cloud.
Okay, great.
Hope that answers the question. I'm more than happy to provide more detail if necessary.
Okay, we'll see what he comes back with, but thanks for that.
Okay, so moving forward, so in the last Moldflow Flex 2016 release, if you wanted to run a DOE, regardless of how big the DOE is set up, we only charge 100 cloud credits, and as of going forward, we will charge more for larger DOEs. So if you add more complexity to your DOE, we will charge more for that. So we before the analysis submits, we give you we provide a pop-up dialog that specifies like how many cloud credits actually are going to be burned, and you can say like, okay, proceed with that. If you say like, oh, this is too much, I don't want to burn 122 cloud credits for this DOE, you can cancel out before the analysis launches. Any other questions that came in on this particular topic so far?
There was a question that came in regarding Synergy, and will we need a different license for that?
For what? For Synergy?
Yeah.
So if the customer has, this is a good point. So if you, well, let me get back to this one. If you had a Moldflow Flex product last year, the Moldflow Flex product came with under one product line. You had both access to Synergy, the user interface, and an Insight Solver license. Once you so everybody should have been configured now with the Moldflow 2017 product line, and people that had Moldflow Flex in the past will have received a Synergy license as well as a Moldflow Insight license, and it would be the Moldflow Insight Ultimate piece. Sorry, somehow it skipped back. So you should automatically have been entitled now with the equivalent configuration you had before from that perspective. So you would not have any loss of functionality there.
Alrighty, I think we're good there.
Okay. All right. Like I said, we can take more questions down at the end. I'll move forward.
Sounds good.
So this year we put also a lot of effort into usability improvements, and I want to make a plug here for the Moldflow Idea Station. Many of you have maybe over time submitted ideas over there and basically maybe provided votes on that. And this is actually a source where when we want to make some usability improvements and allocate some time to that, this is actually a source where we go to and look at the top priority list of the top voted ideas in the Idea Station, and pick from those the highest and feasible items from the list. So if you have an idea or something that you would like to have implemented in Moldflow, I would strongly urge you to submit it to the Idea Station and also provide votes for other ideas that have been submitted by others. So for us, one of the things that we came to hear over and over again when we talk to customers about the transition from the Moldflow Classic interface to the ribbon use interface is that it was perceived as something that would take more clicks than in the highly optimized user environment that customers could set up in the old Classic interface on Moldflow. So one thing we did this year, we actually found out a way to build custom ribbons now. So in this particular case, I have built my own ribbon over here with my own selection tools and the tools that I use on a daily basis. And I can store this, I can save this, I can export a file, and I can, let's say, give it to you and you can actually import this file and actually create the exact same using the exact same ribbon toolbar that I created. So this may be an idea, like if you as a Moldflow expert have some other people working with you that are maybe not as familiar with Moldflow, maybe there's an opportunity for you to, let's say, put a couple of tools together that are like provide an easy workflow for something that they are trained in. Just export that particular toolbar and make it available to them. Otherwise, obviously, you have the benefit of like putting all the tools together that you use on a daily basis, and just have access to those straight away without actually having to click between mesh, geometry, or results. So you can create your own toolbars, the only tools that you need and that you use a lot, put them together in one toolbar. Eliminates a lot of mouse travel and tool clicking, mouse clicking. Another thing we did this year and is we were able to lock the if you have two models you have open and you lock those, we are able to now synchronize the cutting planes. So particularly in post-processing, this is very useful if you want to make sure that sort of you're looking at the same parts in a clipping, rather than having to build individual clipping planes in the two different windows. Now they are completely synchronized and they will move together if you make adjustments. We also now are able to move the legend bar and stretch the legend bar, or modify the size of the legend bar, put them wherever you want to the left of the model, to the right of the model, top or bottom. You can stretch them. You can do whatever you want with that. And this might help you with like putting some, in terms of reporting, create a layout that works for you. Another thing I'm actually quite excited about is the ability to isolate causal warpage with the aggregation option on. So if you have 3D warp model, you wanted to have isolate causal warpage, this is only available without aggregation. This time around, we actually are, but most customers actually use the warpage calculation with aggregation on. But the isolate causal warpage is not available at that time. So we found a way to enable that for the mesh aggregation on 2 now. So a very valuable tool is now available, I think, at a much less computationally intense price point. And we sort of spent a good amount of time on actually creating some automation tools around reporting. And so almost every analysis that or every project we see customers do, at the end of the day, there has to be some kind of a record for it, right? And most of the times, like there's a report template that people use in a company, and there's a lot of time spent creating images and formatting something in a way that is compelling and repeatable. We created some automation tool around creating a good-looking PowerPoint report that should save you a lot of time with sort of putting the basics together. So in this particular case, we basically have a template for like filling, packing. We have a template for warpage that we put together ourselves. But if you have your own company logo or your company PowerPoint template, you can actually switch it out very easily, make some modifications to your scripts, and actually customize it to what you think should be the default standard report that you write. So the way I would encourage you to have a look at this is basically, is there a way for me to standardize my reports into 2 or 3 different templates? If you, let's say, are focused primarily on comparing design A versus design B, and create a report around that, I would say try to see if you can condense that into a base content for that particular type of report, and see if you can put some automation tools around that based on the technology we provided in the 2017 release. So in this particular case, like we have a report, a PowerPoint report showing like 8 different filling progressions. And these are things that are not necessarily easy to construct manually in Moldflow. without actually going back and forth between Synergy and PowerPoint a lot. We've now created this particular tools that actually are able to capture this particular image just with one command line. So in this particular case, we have a flickering progression with 2 different orientations, 8 different snapshots, and a single toolbar next to the side. And that actually is, like I said, it's captured in one particular command line. We also have created some functionality to populate tables easily. So tables in terms of, let's say, material data that automatically gets extracted from the screen outputs. We have created some tables or inside of PowerPoint that are histograms, something that actually the Moldflow user interface doesn't actually provide right now, as well as, let's say, warpage deflection plots in isometric form. And this is all driven through very simple scripts. So we actually included both the templates that I just showed over here in the installer, as well as like simplified scripts that basically drive these all these things. So if you look at the lines over here, every line in this particular plot is basically a slide. So there are many different options available and many different arguments for creating different variations of the different plots. And there's a good amount of flexibility in how you can set up your reports to your needs. It's worth spending a little bit of time on, because it's going to, like, if you spend a lot of time creating reports with populating pictures left and right, better the work can be automated. You're going to save yourself a lot of time just by scripting it once. We spent a good amount of time on our on improving meshing as well. So one of the things that we've spent, we redeveloped the local mesh density creation. So we had tools around this before in the in prior releases, but they were pretty hard to work with. So one of the things we did this year is basically recreated the user interface for it. Now you can select faces and edges and group them together and save them in this one particular group. And you can give for this particular group a specific edge length or whatever you want to. You can create multiple groups with different edge lengths or local meshing parameters, and you can remove features from it and add features into it in that group. So the groups that you create are very flexible and open and can be modified at any given time. So very much more intuitive than I think the prior version was. And we actually also have created some new tools that are basically allow us to directly manipulate the surface mesh. For those of you that have used the Scanim technology preview, this was available, I think, in the last technology preview already. But we can now make non-planar selections. Let's say I can select with 2 mouse clicks the interior surface of the this boss, and I can say move this in a negative direction by 1 millimeter, which gets me this. And then I selected the top surface of this this boss, and it's like extrude this top surface by 10 millimeters. So in 3 steps, basically, I made a fairly significant change to my model that is non-trivial. So normally I would have had to go back to my CAD system to actually make these design changes, but actually I could do this on the surface mesh directly. So this is a surface mesh editing sort of surface mesh editing tools. They're not on the CAD model. We have some other work in progress on the CAD model to modify CAD faces and such, but that's not ready for prime time just yet. So this works on surface mesh, not on a 3D mesh. So if you wanted to do this on a 3D mesh, you have to strip the model back down to a surface mesh, make the design changes you want, and create a TED mesh from that again. With the technology, we also inherited a number of new selection tools. So in the last release, we had the ability to select planar surfaces, but we also now added the ability to quickly do non-planar selections. So everything that's connected in a non-planar way. In this particular case, I started with a seeding point on the edge over here, and I asked it to do a non-planar selection. Everything around the edge was selected at the same time. We also had extended the selection tool now to include tetrahedral surface selection. So I started off with a seeding point on the top surface. I said select everything that's planar to this particular face, for all the tetras that are planar to this particular face in a selection. And we added selection tools for nodes as well. So I can now do a quick selection of node on an edge, as well as find all the nodes that are basically on the same plane. I want to say, though, that the select node on the edge is does order the nodes on by node number, not by geographical spacing. So if it does not order them along an edge neatly unless the order of the nodes are actually in numerical order. There's still a little bit more work to be done, I think, to I think it is a good use case to be made for like selecting by geographic location or geometric location. Are there any questions out there for me so far?
Yeah, there's a couple that came in. In terms of the report generation, yep. Harold was interested in knowing if you can use an older Office package. Sounds like you might be working on 2007.
It should. I think it uses the common tool, the APIs from Office. Although I'm not entirely sure how far back we've tested this. So I would say no, but just give it a try. We have a number of templates available, and it's just a matter of just trying out. If it doesn't work, then we'll find out very quickly.
Right. Alrighty. And then he also asked, will the node numbers stay the same after an extrude or move operation? So when you were talking about the mesh modifications. Yeah.
Good question. I think the extrude. Let me go back to this. I'll have to look into whether or not the elements that are extruded, like if you go to this,
Hanno,
elements
this is Jay.
Hey, Jay.
Yeah, I'm playing with it right now, and the answer is no. The node numbers will not stay the same. I'm currently using the offset command, and they change, and I'm pretty sure the same thing would be true for the extrude.
Okay, thanks for jumping in there.
Thanks, Jay.
There may be this may be a good enhancement that might be fairly low hanging fruit to get added down the line. So.
Alrighty,
good suggestion. Now,
yep. Yeah. Add that to the idea station, I guess. And
good
then, yep, that seems to be all the questions at the moment.
Okay. All right. All right. Move on. So we've rearranged our flow solver team extensively in the last year. So where in the past we had a solver developers that were specifically focused on one particular domain, we actually built a flow solver team this year. So everybody's working on the same 3D flow code right now, and we actually brought in. Also, developers for, let's say, the meshing team. The meshing team have now representation in that flow solver team, as well as we brought in some QA members in those teams. So they're now functioning as a unit that is all about improving accuracy and from all angles, if you will. So as an outcome of that, we actually made a number of a good number of solver-specific enhancements to the software. There's a fair number of minor well, not so minor, but like subtle changes that we made to the flow solver that are a bit more nuanced to cover over here. I don't want to make people fall asleep with the gory details of flow solver technology. But one of the other outcomes is basically of those benchmarks is basically, or the focused development teams is basically that we made some rational decisions on bumping up the number of elements to a thickness from 6 to 10 by default. So, and this is something that I think most customers already did by default now anyway, and we've been making sort of hints that would be a good idea over years. But we have not actually formalized it ourselves in the default behavior change. This has obviously, like, we will see a little bit of an increase in the element count as a result of this. At the same time, though, the structure is a little bit more efficient as well, so we don't see necessarily as many dense patches of TET elements appearing, and the measure itself is actually a lot quicker too, like about 20 to 30% quicker this year for creating TETs. The other thing you'll notice is that the structure of the mesh was in the prior release. We will typically see the diagonals sort of going in the same direction. That can actually numerically skew results a little bit, a tiny little bit, and that can over time, or like while the analysis progresses, small numerical instabilities can actually start progressively worsening the final result. So one of the things we did this year is basically change the structure of the TET mesh and sort of make it alternating. So whereas a diagonal goes in one direction in one layer, the next layer will try to create a diagonal the other direction, and sort of creating a bit more randomness in the TET mesh itself. And that helps us actually avoid some of the numerical skewing that could take place in some particular cases. So this was actually like a fairly big change, and like I think when we established the initial 6-layer TET minimum through a thickness, that was like 10-15 years ago, and the amount of compute power was available 10-15 years ago is very different from now. I think it was high time to rebalance or to take a step back and actually see if that the 6th layer was still the appropriate way to go. And actually we decided to err on the side of accuracy versus compute power, if you will. Some other changes we made, and this might not be important for everybody, but if you are doing compression molding, in the prior release, we were able to give you some initial orientation, the ability to provide some initial orientation of the elements, but this was typically sort of following the main axis. We now actually are allowing to give you the initial orientation of the fibers in that particular charge at any point in like any spatial direction, if you will. So it's a bit better implementation. I don't think it's going to matter for everybody, but for specific customers, this is important. A much bigger change that is more impactful for most people, I would say, is that we moved the fiber orientation parameters that were always part of the solver parameters. We moved those over to the material data. Over time, over the years, we've in discussion with material suppliers, we found that there's a good amount of evidence that you could treat, let's say, a default fiber orientation model or a default set of RSC parameters for the fiber orientation to be a material property. And material suppliers have spent a good amount of time understanding which parameters work best for specific materials, and this allows them to actually provide us with, we would recommend our customers to use, let's say, an RSC model with a specific set of RSC parameters attached to it for 3D models. So we can now actually take material-specific fiber orientation data and fiber orientation defaults. That's going to help us actually going down in terms of accuracy as well, because, like I said, some of the material suppliers have really good data on what works better than our initial default settings for their specific materials. For some customers that are interested in doing hybrid overmolding, let's say overmolding a composite structure, a thermoplastic composite structure, we allow people to now specify anisotropic insert properties. In the last 2 releases, I believe, we add the ability to specify orthotropic material properties. Now we allow it to be like fully anisotropic, so it's like the superset of the orthotropic way, if you will. So I think it allows some customers to build connections between draping codes that they already have access to, and use the information created by draping and forming codes to provide material stiffness at every point in an insert, if you will. This is actually a really good improvement as well. I think until now, in terms of overmolding, we were only able to start with flow and run all the way through warp, but we never were able to actually account for cooling effects. So this time around, we equipped our cool FEM solver to run also with an overmolding scenario, and I think we did it properly this time. So it's we allow you to set up sort of 2 of the most common scenarios. First is the rotating platen, and I've highlighted the rotating component over here, that it will be indexing and going from the first shot. The part that's in the first shot will actually turn around and become part of the second shot, and the overmolding takes place over there. Whereas in that's the rotating platen scenario, and there's another scenario that's fairly common. It's the indexing cube scenario, where you have an injection unit on this side and you have an injection unit on the other side, and the cube indexes like 180 degrees every shot. So we can take it in our cooling solver now, take into account both scenarios and show you what the mold cooling looks like. I would still say that the setup and of this is I would say not trivial and up for improvement. But as you can appreciate, like, it is a very complex set of mechanics that have to be dealt with. So setting it up is actually there's almost no way to make it super easy. We're still looking at simplifying this down the line, but I think this is a very good first step. There's a number of customers that are starting to use increasingly more liquid silicon rubbers, or LSRs. We had a very limited number of LSRs in our database, and this year we actually expanded this by, I think, roughly 15 to 20 LSRs in the database. So of sort of very common material suppliers. So hopefully this becomes something that our customers are going to be able to use more. We're interested in building this out further, so if there's materials that are missing that you use on a very frequent basis, and you have a good contact with the material suppliers, please help us establish those connections, and we'll try to expand the size of the LSR database. Another thing that we fixed this time around was the ability to have a thermoplastic insert in a thermoset overmolding scenario, or if you have a thermoplastic overmolding scenario, you can now also assign a thermoset as a part insert. So that was something that wasn't like blocking us. If you want in prior releases, you want to do an overmolding, you want to define a let's say you were to do a thermoplastic overmolding. You only had access to a metal database for inserts, or plastic database inserts. In the plastic database is only the thermoplastic side of the database, not the thermoset. This is now changed, and you now can define any kind of thermoplastic or thermoset insert in any kind of thermoplastic or thermoset overmolding scenario. We also spent a good amount of time on adding sort of new foaming capabilities inside of Moldflow. The first thing is basically in addition to the MuCell capabilities we had already in 3D in the last year, we now expanded this to include a coreback scenario. So you can buy, as most of you know, sort of in the MuCell or the blowing agents capabilities, actually the bubble size and bubble density is very, very much driven by the pressure drop that occurs during packing, or like, the way you can massively improve the structure of the foam is by moving the core back. In this particular case, you see this animated over here. By moving the core back, you see the number of the radius of the bubbles significantly increase, which is basically creates a much better foaming structure than we'd normally get with conventional MuCell. Typically, with MuCell in its conventional form, for instance, you would get anywhere between 8 and 12% weight gains. With this particular coreback technology, you can go way beyond 20 to 25%. 40%, I would say, if you do it well. So it also opens up the scenarios like, how can I, what should the size of my mold be, that after coreback I get my, how thin can I make my cavity size, if you will, for to get to the part that I want. So we can actually run a number of scenarios. Maybe we can make some modifications with the new mesh modification tools that I showed earlier to quickly make the initial part thickness thinner, and then moving the core back to accommodate for the thickness change. And actually, but you get actually a better foam structure in the middle than what you would normally get with your conventional MuCell. So. We also added the ability to use chemical blowing agents, or CBAs, also commonly referred to. What you would have to specify is the ability, how much chemical blowing agents weight you added to your material, as well as like how much of that chemical blowing agent solid material will actually be converted into a gas. So once it's in a gaseous state, it effectively follows the same sort of process that you'd normally get with the MuCell process. We also added the ability to run induction heating analysis or rapid heating and cooling analysis in combination with the foaming technology, either chemical blowing agents or with coreback. This particular part was demonstrated at NPE last year, a big trade show in the US. It was running a MuCell molding process on an angle with a very high quality finish, high gloss, low gloss part. So normally with MuCell you would actually never get this kind of surface finish, but with the introduction of rock tool technology, like you could actually locally heat up the mold surface and actually get even with an induction heated so with a MuCell molding process, you can still get a super high quality surface finish. So all these like little things over here are like low gloss textures that are etched into the mold. So with that technology, even with MuCell technology running behind it, you can get a high quality surface finish. So it opens up a lot of doors, I think, for applying MuCell in other areas. So we open it up in our simulation as well. So this time around, yep.
Sorry, Hanno, before you go on, there was a couple of questions that came in that I wanted to quickly hit. Do we have documentation out with the release on flow solver speed improvements?
We do have that part of the validation documents. They're still at the moment being sort of reviewed by a number of people just to make sure that they're ready to go. I expect those to be the validation documents to be available. I'd say end of next week.
And that will be in the
on the Autodesk sort of the Autodesk accounts in the area of product enhancements.
Okay.
I can. So once they're available, I'll post something on the discussion forums, hopefully with a direct link to those pages.
All right, and one other thing that you mentioned before, could you reiterate the meshing time improvement for Tetras?
So the meshing, we have a new scheme of creating those test meshes, and I think we see like a speed improvement of up to about 30%.
Okay, great.
So, like we will get typically some more elements in the model. At the same time, we actually are avoiding a lot of the some of the patchy or like very high density patches that we were seeing in some particular cases. So, I think across the board we actually did a good job minimizing the impact of creating more elements, if you will, in the model.
Great, thanks, Hanno. Sorry for stopping your...
That's more okay. Another thing we did this year is basically added cooling capabilities to the gas-assisted injection molding. In this particular case, like you see how a mold core, so a gas core gets hollowed out, but I also have cooling analysis results on this. And we added some new, and this is again not maybe the most useful thing for most customers, but it allows us to actually build up some really good connections with research institutes or some special research groups in larger companies. We added some additional solver API functions in the Moldflow flow solver, so the Moldflow solvers. So last year we introduced a first function of being able to create your own viscosity model inside of Moldflow. Now we have expanded this to creating your own PVT model for Moldflow, as well as core shifts. So with this, it helps simplify a lot of the research activities we have going on. It allows research institutes to develop directly within our code, and actually make a lot more quicker iterations in moving science move ahead faster. So, like I said, this is maybe not the most relevant thing for most customers. At the same time, it allows us to make some tweaks to certain things. I think maybe even for that are like for special niche customers, if you will. Like a customer has a specific request for some capabilities, rather than upsetting the entire code, we might be able to quickly make a couple of API calls in our in a script form, if you will, and provide like the end user with a custom version of that, if you will. So it has some interesting implications. I mentioned earlier that the fiber orientation parameters moved from the solver parameters to the material data, the UDB files. With that also comes the capability of making some of these data sets confidential. We found that so even though some material suppliers have a great amount of experience in tuning the fiber orientation parameters in specific cases, they also spend a lot of time doing that, and they see that those particular tuned parameters as some of their intellectual property. So they requested us to also while we actually move those over to the material data, to also provide a way to hide the explicit data points, if you will. So we have now extended the ability to hide certain data fields. Like I said over here, this is how it would look in the user interface, and the data fields that are hidden would also show up in the log file as confidential. We will accept in the database, in the commercial database, if you will, or the public database, very specific data sets to be hidden. Like if the customer has, the material supplier has better data sets for, let's say, RSC parameters for fiber orientation or nonlinear mechanical data that they want to have classified, we will honor that. We will not go to the point that we also allow a customer to add, for instance, confidential PVT data, or because we do think that these things are very important for the end user to understand, because it's part of the DNA of the material. But at the same time, if the material supplier is adamant that they want to make more data fields classified, we are going to be providing a special tool to everybody where you can basically import a UDB file, a normal Moldflow material database file that they may or may not have edited, and specify which data fields to hide or make confidential, and they can then directly transfer those new UDB files with the hidden data fields to their end customer, and work that way directly with the end customer. Like I said, we will not hide every data field in Moldflow going forward. Just specific data sets that we think are okay to hide, we will accept in the public database. But if there's data sets that need to be hidden outside of that, you can actually use a third-party tool. This new tool, this third tool, is not available just yet. We're still coding on it. It's actually very close to be able to make available. As I say, in the next month or so, we should have that available to everybody. Are there any more questions?
Yeah, Hanno, there's a couple of questions about the new chemical blowing agent simulation. Wanted to reiterate that this is sort of a variant of the MuCell process, right?
Correct.
So you have to have the ultimate license, and instead of picking MuCell, you pick the chemical blowing agent and then put in the given parameters. Also, there's been a couple of questions about chemical blowing agents for specific products, such as shoe soles.
Yep. I think at the moment, like particularly the shoe industry, they have I think very specific processes that are not necessarily covered by this particular chemical blowing agent. So we are aware of some of those. We've had discussion about with some of the shoe suppliers. I think there's definitely more work to be done to actually cover those processes. But I think they are. I think a lot of the information of how those processes work are not public information. So. That's still something we can look at expanding into, but that would be like probably a one-to-one conversation rather than a very open structure.
Okay, I don't see anything else that we haven't covered.
So in interest of time, I'll skip the videos over here. I can make those available at in a different place down the line. I do want to cover real quick SimStudio tools. It is a companion product that we've had last year as well, and this is sort of the next incarnation of what people would have been familiar with under the name of Inventor Fusion. So SimStudio tools are basically built up on a very similar platform as Inventor Fusion at the time, but it was completely redeveloped and a lot more robust nowadays. So it has a lot of capabilities to simplify models, to remove, let's say, radii, and basically you can import this particular case, I imported a step file, and basically had a slider over here to explore specific parts of geometry, let's say fillets or radii. And I have a slider over here that can actually specify like how big of a radius or small of a radius I'm actually trying to capture. And once I actually selected those things, I can actually delete those and actually get like straight corners. It is an interesting technology we've had access to, and actually we are starting to also provide some technology into this particular framework as well, to allow even more modifications of third-party CAD models. So if, let's say, I want to make a CAD modification over here, you can select the surface and actually just drag it out by a specific distance. There are still some limitations on what can be done there, and like I said, this is the area that we are starting to provide some new technology in terms of the ability to morph sort of more complex CAD geometry, like free-form surfaces that are really hard to deform now with SimStudio tools. But I think down the line we will get there. Another product in our ecosphere that's become very influential and very important is the Helios PFA, and we're going to actually rename it to Helios PFA for plastics, where we can basically take a Moldflow model with Moldflow fiber orientation data and take an Abacus or ANSYS model, a solid model, and map the Moldflow fiber orientation to the ANSYS or Abacus model. And then if we have access to nonlinear mechanical data, we can calculate the nonlinear mechanical properties for every part of this particular model. So you can actually start looking at things like failure instead of Abacus and ANSYS. So we've had this capability for like about a year now commercially, and it's been moving very fast. And actually, the next incarnation of this this technology is going to come out in a very short future. So the intent is to come out with the ability to handle assemblies, as well as predict weldline strength. So in the last release of Moldflow, we were able to, for 3D models, capture the position of weld lines and where the weld lines ended up. We're now also looking at extending that capability to capture sort of the temperature history and the pressure history of those weld lines as they were formed, and do an assessment on the weld line strength at that time. The other thing we're doing is we have nonlinear data on tensile direction, but we're also like starting to provide opportunities to add data for compression. So the materials tend to behave a little bit differently on a compression scenarios as they are on the stress tensile scenario. So to a leading order, they look very similar, but once the part fails on a compression, the failure behavior is actually quite different. So we'll add that capability inside of the technology as well. And that leads me to the end of my presentation. I think we're just a little bit over time. If we have any additional questions, I'm more than happy to start answering those. And if not, then I can also take them offline later on. Just send me an email. Are there any more questions out there?
It looks like there's a question. Does Helios PFA use difference license?
Yes, Helios PFA uses a separate license to the Moldflow Insight product or the Moldflow product line. So there's a separate license requirement for that. Yeah.
And can we simulate ejection systems?
We have the technology available in the scanning technology preview. We did not think it was quite ready for prime time yet. I think particularly the setup process was not quite there yet. I think we're close. The ejection force calculation is, like I said, at the moment still available in the scanning technology preview. So if the customer has access or wants access to that, they can continue using that on the 2016 license.
Alrighty.
We intend to commercialize that over time for sure.
Yeah. How about what's new in Moldflow Advisor?
So a number of these things actually are also relevant for Advisor. Just top of my head real quick, the ability to create your own toolbars is part of the Advisor workflow. The aggregates, so the isolate cores of warpage with mesh aggregation is also relevant for the Advisor workflow. We do intend to actually spend a bit more time on Advisor in the next year, the upcoming year. I think particularly in terms of repackaging and the how the workflow works with for instance, the Moldflow Design product. I think there's a fair bit of confusion around that. I think we want to start eliminating that a little bit more. So Moldflow Design, as you may have heard also under the name of Moldflow DFM or DFM, is still available under the Advisor license, and actually that has also been updated to the 2017 release, and is still available under the Advisor license. In terms of new functionality or new capabilities, this year we did not add anything like sort of a new simulation feature in there. A lot of the accuracy improvements that were mentioned before over time are also relevant for the Advisor product line. Automatically we'll get absorbed into that as well.
All right, great. We have received some requests about the possibility to simulate foaming processes, standard foaming process, so bigger cells than the average mu cells. Is that something that we can be done in chemical foaming agent solver?
I would say at the moment, like if this is a particularly open foam, I would say, or just more like a foam casting process, I would say is going to be a lot harder to simulate, even for us to actually develop, because it actually is a very different process, I would think. The polyurethane foaming is also like a very different foaming process, I would say, than what we do right now. So it was never developed for this. I don't think we necessarily have any validation data that this works well or it can be extended very easily in this particular direction. So I'd say that at the moment it's not supported, but we are getting requests for this these type of foaming processes outside of the sort of the mu cell ecosphere, if you will. It is an area that we're looking at and are interested in developing further. We have, I think, so we are part of a consortium at the University of Toronto, where I think a lot of the validation work and the development work that we've done actually is coming from or has been driven by. At the University of Toronto, they also have access to the other foaming technologies that are available. So we definitely are going to take this one step at a time, and I don't think we should expect this in a very near term. I think that's probably worth indicating.
Alrighty, and can we use the overmolding function to simulate rotary plate and vertical machines?
I would think so. I wouldn't know why not, actually. It may be worth having a separate call on it, because I'm not entirely sure I have a good understanding of where the question is coming from. I think we looked at a decent amount of different variations of the overmolding technology. I think the the two scenarios I basically sketched out over here were sort of the two most common ones that came up a lot, but there are definitely like about another 10, 15 variations out there. I think some of them can be covered to a greater or lesser extent, I would say.
All right.
So like I'm more than if they can provide me like their contact details, I'm more than happy to have a conversation around that.
All right, I think we can get you that information. I'll follow up with you. Yeah, that looks like it's all of the questions that really have come in. So I want to thank you for your time today and staying on and answering these questions. They're all really good, and it's useful for the users to know what's lying ahead. So
yep,
I appreciate it.
Good. Yeah, thanks everybody for joining the call. I think I'm actually very excited about this release. I'm actually really interested in hearing what your feedback on it as well. So feel free to drop me a line. My name is Hanno van Raalte at autodesk.com. My email, I think, is somewhere as well in the top, but it would be hanno.van.raalte@autodesk.com. So thanks everybody.